Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 10.3, Solving Quadratics. A quadratic equation is in the form y equals ax squared plus bx plus c. X-intercepts are the zeros of the function. That is where we're going to cross the x-axis, so our y value would be 0. Solutions are the roots of the equation. We get solutions when we take and square root our x value. Okay? So for all four of those terms mean exactly the same thing. X-intercepts and zeros, solutions, and roots all mean exactly the same thing. All right? So we can use them interchangeably if we want. So for some graphing, we're going to solve each equation by graphing the related function. All right, so the first thing we need to figure out is our axis of symmetry, just like in our last section. That's going to be our b value. Well, our b value should land in between x squared and our c value, which is -4. In this case, there isn't one, so it would be 0 over 2 times 1, because it's the opposite of b over 2a. This would get me 0. So that means my vertex is going to be 0, comma, I'm not sure yet, because I need to take my 0, plug it back in for my x squared. So to find my y, I would take 0 squared minus 4. That would get me -4. So my vertex is at 0, -4. If I start at 0, 0, I would have to go down to -4. Okay? Also, I need to remember to plot my axis of symmetry as a dashed line, just like in our last section. Now to finish off my graph, I need to make a table. And just like in our last section, the vertex will go in the center. Going to the right, I add 1. Going to the left, I subtract 1. Now, you don't have to write all this out when you try to solve for 1 and 2. For x equals 1 and x equals 2. I'm going to write it out right now, but you could also just always use your calculator. So I'd take 1 squared minus 4 would get me 1 minus 4, which is -3. Remember, since they're symmetrical, -1 would also be -3. And then I have y equals 2 squared minus 4. If I put 2 in for x, that would be 4 minus 4. So my y would be 0. Okay? If I go ahead and plot those points, from 0, 0, go right 1 down 3. And I go left 1 down 3. And then from 0, 0, I just go right 2. And I go left 2. So my solutions are going to be where I cross the x-axis, which is here and here. So my solutions are 2, 0, and -2, 0. All right? On to b. I have x squared plus 4. So again, I do not have a b value. So when I go to find my axis of symmetry, the opposite of b is going to be 0, because I do not have a b value. So x equals 0 over 2 times 1, which is 0. So my vertex is going to be 0, comma, I'm still not sure. I have to put 0 back in for x. So y equals 0 squared plus 4, which means that my vertex will be at +4. So if I go from 0, 0, I need to go up 4. That is my vertex. My axis of symmetry, again, will be at 0, so it's going to be the y-intercept. Now I need to fill in the rest of my graph, so I'll have an x and y. 0, 1, 1, 2, 2, 3, 3, 4, 4, 5. Put my vertex in the center. Add 1, subtract 1, subtract 1. Again, if I put 1 in for x, I would have y equals 1 squared plus 4, which is 5. Go ahead and plot those points right now. From 0, 0, I go right 1, up 5. From 0, 0, I go left 1, up 5. Whoops. Now, I need to solve for x being 2. So y equals 2 squared plus 4. 2 squared is 4, plus 4 would get me 8. So again, I start at 0, 0, I go right 2, up 8. and I can go left 2, up 8. If I go ahead and connect all those points, remember that my solution would be where my graph crosses the x-axis. Since that does not happen, I would have no real solution for this problem. All right, let's continue on to C. C, I have the same issue with my b value. I don't have one. So as I go to find my axis of symmetry, I'm going to have x equals 0 over 2 times a, which is also 2. That will get me 0 for my x value. So my vertex is going to be 0, comma. Now I put 0 back in for x. This would be y equals 2 times 0 squared minus 18. That would get me negative 18. I go ahead and plot my vertex at 0, negative 18. Start at 0, 0. Go down to negative 18. Also, again, just like my last two, my axis of symmetry is my y-axis. That is not always the case. It just has been for our first three here. At this point, I need to go ahead and make a table. I'm going to put my vertex in the center. I'm going to add 1, subtract 1, subtract 1. If I put 1 back in for x, it would give me 2 times 1 squared minus 18, which would be 2 minus 18, which is negative 16. Then I need to solve for 2, be 2 times 2 squared minus 18. 2 squared is 4, 4 times 2 is 8, 8 minus 18 would be negative 10. This is symmetrical, so I can continue there. If I go ahead and plot those points, start at 0, 0, right 1 down 16, left 1 down 16, then I can go right 2 down 10, and I can go left 2 down 10. You'll notice that my graph is starting to get closer to 0, or the x-axis, but it hasn't quite reached yet. If that's the case, I'm going to add one more number to our table. So I'm going to try 3, see if that works for me. So 2 times 3 squared minus 18. Well, 3 squared is 9. 9 times 2 is 18. So 18 minus 18 would get me 0. So that would mean that negative 3 would also get me 0. If I plot those points, I go to from 0, 0, I move right 3, and I move left 3. Now I can connect all my points, and I have my answers. So my solutions would be 3, 0, and negative 3, 0. Okay? On to x squared minus 16 equals negative 16. What I need to do here to start with is go ahead and add 16 over. So I would get x squared plus 0 equals 0. I can find my axis of symmetry at this point. I don't have a b value, so again it would be 0 over 2 times 1 is my a value. So they get me 0. My vertex is going to end up being 0, comma, don't know at this point. Alright, so now that my x value is 0 for my vertex, I need to find my y value. In order to do this, what I would have to do is plug my x back into this line. So if I do that, I'd have 0 squared is equal to 0. So 0 squared, y would equal 0 squared, I apologize. So it'd be y equals 0 squared, which is then also 0. So my vertex at this point is 0, 0. My y-axis just so happens to be my axis of symmetry again. Now I need to find out the rest of my table. So I'd have my x and y values. Put 0, 0 in the center. 1, 2, negative 1, negative 2. I need to put 1 in for, again, this line here. So it would be 1 squared is equal to 1. And then 2 squared is equal to 4. Go ahead and plot those points. I go right 1, up 1. I go right 2, up 4. Left 1, up 1. Left 2, up 4. Connect all of my points. And I have my equation. Now, there's only one point that even touches the x-axis, and that is 0.00, so my answer is 0, 0, and I am done. On to the back. Now that I have 3 terms, I'm not going to change anything on my entire process. I'll have the axis of symmetry be the opposite of b, well, my b value is 5, and then it'll be 2 times my a value, which is 1. So this will give me negative 5 over 2, which is actually negative 2.5. That means my vertex will be at negative 2.5, comma, I'm not sure yet. So what I need to do is take my negative 2.5, plug it back into the original equation. So negative 2.5 squared plus 5 times negative 2.5 plus 6. What that is going to end up getting me is negative 0.25. I don't know why that's on there. I'll get rid of it for you. So this would be negative 0.25. That means my vertex is at negative 2.5. So I start at 0, 0, move left 2.5, and then down 1/4. So it'll be somewhere in that area. You're not going to make it perfect at this point, so just do your best. Also, my axis of symmetry needs to go the vertical line right where my vertex is. Now to find the rest of my points, what I need to do is make a table. So I have x, y, 0, 1, 2, 3, 4, 5. My x value is going to be negative 2.5 in the center. My y value will be negative 0.25 in the center. Now instead of adding 1 when I'm going to the right and subtracting 1 when I go to the left, what I'm going to do is add what I need to get to the next largest whole number. So in this case, what I would have to add is 0.5, which would get me to negative 2. From negative 2, then I could add 1, which would get me to negative 1. Going the other way, I would subtract 0.5, which would get me to negative 3. Then I can subtract 1, which would get me to negative 4. I don't want to mess with decimals as much as possible. I want to not have to deal with them unless I absolutely have to. I absolutely had to with my vertex. So for that first step, my first point, I'm going to actually add what I need to make it a whole number. All right. So if I put negative 2 back into the original equation, I get negative 2 squared plus 5 times negative 2 plus 6. That will get me 0. And then if I put negative 1 back in the original equation, that would end up getting me positive 2. So now that I have my table, I can plot my points. So start at 0, 0, go to negative 2, 0, and go to negative 3, 0. Then I can go to negative 1, positive 2, and negative 4, positive 2. Connect all my points, try to make it look like a U. And I have my graph. There are 2 points that are on the x-axis. That would be this negative 2, 0, and this negative 3, 0. So my answers would be negative 2, 0, and negative 3, 0. All right, on to our last problem. For the axis of symmetry, be the opposite of b. Well, negative 8 is my b value, so I'll have 8 over 2 times my a value, which is also 2. So you get me 8 over 4, which is 2. So my vertex will be 2, comma. Now I need to take my 2, plug it back in the original equation. So it would be y equals 2 times 2 squared minus 8 times 2 minus 10. If I type all that through straight in my calculator, I end up with negative 18. So my vertex is at positive 2, start at 0, 0, right 2, down 18. My axis of symmetry is the vertical line at that location. Now I need to make my table, so x, y. Actually, before I do x, y, let's just see if this will work out. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Put our vertex in the center. Add 1 going to the right. Subtract 1 going to the left. If I put 3 back into the original equation, I will end up with negative 16. Then if I put 4 back in the original equation, I'll end up with negative 10, which means that I have not found my 0 yet, so I need to add one more to it. So if I put 5 back into the original equation, I end up with 0. Okay? Remember, this is symmetrical, so I can just fill in the other side. At this point, I can go ahead and plot my points. So I go right 3 down 16, right 2 down, or right 1 down 16. Then I can go right 4 down 10, stay at 0 and go down 10. And then I can go right 5 and be at 0, and then left 1 and be at 0. If I connect all my points, I have my graph. My answer will be at negative 1, 0 and 5, 0. So then I am done with that. So our summary. When graphing, if I have two solutions, that means I'm going to have two x-intercepts. When using square roots, it would be the square root of a positive number. If I have one solution, I'll have one x-intercept. It would be the square root of a 0. And if I have no real solution, there would be no x-intercepts. And it would be the square root of a negative number. Well, that is the end of our lesson. Make sure that if you have any questions over any of this stuff, you come in and see me. Most of what we did today was just review. We just basically picked out where our answers would be from what we already knew about graphing. Again, if you have any questions over this stuff, please come in and see me. Otherwise, thank you very much for watching the video, and have a great day.